chat group a teaser about what are the questions that we are going through today. So today we will be going through 9 challenging questions. Hopefully we can go through them in time. But if you have any other questions that you wish for me to go through, you can either pop it down in the chat below and we will go through it if we have any time. Okay? Otherwise, you can post it in our WeChat group as well, and I will get to you after this. All right, so it's 7:11 now. Let's wait for 4 more minutes for more students to join in, and then we will start at 7:15. So if you are here already, maybe you can share a bit about how you find this paper. Is it easy? Is it difficult? And just a little sneak peek, the next paper will be released in this Friday. Okay, and the difficulty is going to be a bit higher, all right? So hopefully we can just prepare ourselves through this live stream, and then you can better prepare yourself for what's gonna come on Friday, all right? Hello, I see more and more of you entering. We will start our live stream in 2 minutes, okay? In the meantime, maybe hydrate yourself, okay, drink some water, get ready with your pen and paper, and also the completed worksheet or the real paper that we have sent earlier, okay? And then we can put together in some problems. All right, so there's 1 minute left. Okay, for those who have just joined, hello. Hopefully you have completed your TASMO real paper from 2023, and we will be starting our live stream and our analysis in 1 minute. Okay, so hopefully this paper is not that difficult. Yeah, so if you have any problems that weren't addressed in today's live stream, you can talk about it in the group chat and we will see how we can help. All right, I will answer to all of your other questions after this live stream. So let's wait for 1 more minute. All right, it's 7:15, so let's start our real paper analysis for 2023 P1 TASMO. So first of all, you might wonder, wait, last week is teacher Ollie, right? Who is this guy over here, right? Who's that teacher? So let me introduce myself a bit. My name is teacher Yong Lam, okay? I'm not teacher Yong, I'm not teacher Lam, I'm teacher Yong Lam, all right? So I am also a P1 teacher in Think Academy, and today I will be going through the 2023 P1 TASMO real paper with you all right? So if you are excited, please show me your excitement in the chat, all right? So I see, ooh, okay, people are getting hyped up. I see lots of likes. Okay, so without further ado, let's talk a bit about the agenda today. So first, please make sure that you are prepared with the complete paper of your 2023 TASMO, and also be prepared with some stationery, your pencil, your red pen to mark your paper, make some notes, and most importantly, remember to have a good mood and smiling face as we go through the questions together, all right? So without further ado, let's take a look at our challenging questions of the day. So we have received feedback that, hey, there are some questions that you would like me to talk about, and here are the list of questions that I will go through, okay? 4 from section A, 2 from section B, 1 from section C. So these are not all the problems that we will go through in the paper, okay? If you have other questions that you wish for me to go through, either A, if I have time later, I will go through some more of them, or B, you can raise them up in the group chat after this live stream, and I will try my best to attend to your queries, all right? So without further ado, let's start off with section A, multiple choice questions. I can see that there are some traps here and there. Let's look at them together, all right? So question 2. In question 2, we see that a string was twisted. Wow, so many twisting and turning. And a card, okay, let me adjust the pen's thickness. Hold on, give me a moment. All right, we want to cut through the string in the middle as shown. Okay, how many parts are there after this cut? So you see, this is such a complicated diagram, okay? Some of you might think, okay, I'll just count 1, 2, etc., etc. But this is going to be very time consuming, all right? So let me introduce you a trick to handle such problems. Now, this is actually an interval problem. So let's look for some pattern if we cut strings, okay? First of all, I have one cut. I cut the string one time. How many pieces do you think there will be? How many pieces will there be if I cut once? Okay, type in the chat. Will it be 1 piece or will it be no pieces, 2 pieces, 3 pieces? Okay, if I cut it once, how many pieces do you see here? Right, there are actually 2 pieces. Very good. I see some responses in the chat. Okay, keep it coming. What happens if I have 2 cuts instead? I cut it 1, 2 times. How many pieces can you see? Is it 2 this time? Maybe not. Count again, okay? How many pieces are there? There are actually 3 pieces. That's right. Oh, can you see a pattern coming? Let's continue. Let's say that I made 3 cuts this time, okay? 1 cut, 2 cuts, 3 cuts. How many pieces will there be? There will be, again, we have 1, 2, 3, 4. So 4 pieces actually, all right? So 4 pieces. And what happens if I have 4 cuts? 1 cut, 2 cut, 3 cut, 4 cuts. How many pieces will that be? Think about it. 1, 2, 3, 4, 5. That's right. We actually have 5 pieces, okay, of the rope or the string. So what do you notice? If I make 1 cut, 2 cuts, 3 cuts, 4 cuts, my number of pieces will be 2, 3, 4, 5. Do you notice any relationship between the number of cuts and the number of pieces? Are they the same? Can I say that the number of cuts is equal to the number of pieces? Maybe not. Okay, so what's the relationship? Well, you can say that the number of pieces is actually 1 more than the number of cuts that I have made. Okay, so the number of pieces is the number of cuts plus 1. Yes, I see plus 1, plus 1, plus 1. Very good. All right, so now think about it. If I have 100 cuts across my string, how many pieces will there be? Think about the relationship that I've talked about. Number of pieces is equal to number of cuts plus 1. So if I made 100 cuts, how many pieces are there? Oh, I see a lot of correct answers coming in. Keep it up, keep it up. How many pieces are there? Is it 100? Maybe not. It is 100 plus 1. Okay, so it is how many pieces? 101. Okay, good job for everyone who responded. You all got the correct answer. So instead of counting how many pieces are there, let's just count how many cuts are there in this string so that we can decide how many pieces there are. All right, so remember, number of pieces is equal to number of cuts plus 1. So let's count how many cuts are there together. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 cuts, all right? So there are actually 12 cuts in the string. So if that's the case, how many pieces are there after cutting? If I have 12 cuts, how many pieces do I have after I cut this string, or how many parts are there? Oh, 12, 13, 12, 13. 12 is the number of cuts, and the number of pieces should be, that's right, 12, don't forget, plus 1, and that will give me 13 pieces. All right, so where's 13? 13 is E. All right, so I know that my answer for this question will be E. All right, so write down letter E over here. So yeah, give me a 1 if you understand this question. Okay, this is an interval problem. If you cut it for how many times, the number of pieces will be number of cuts plus 1. Okay, now give me a 1 in the chat if you can understand this question. Okay, this is kind of tricky. Yeah, and if you see similar questions in TASMO or other competitions, be very careful. Cuts and pieces, there is a difference, all right? So, I see a lot of what's in the chat. Thank you for your support. Okay, and now let's move on to question 3. Question 3? Really? Question 3 is actually what I will consider a 3-mark problem because it is actually a very simple question about geometry. And in this case, we have 5 monkeys, and we are actually asking which of the following options is different from the rest. We are actually looking for a monkey that is the odd one out. Okay, so how do we find out what is different about these monkeys? This is actually monkeys that are rotated. So these are monkeys that have gone through rotation. And when we see a question about rotation, be prepared to identify and compare any special features you can see in these monkeys. So what are special features? What is so distinct and identifiable about this monkey? For example, I can say that, oh, a monkey has a head, right? So let's just see what direction is the monkey looking towards. So for example, in A, the monkey is looking towards the left, right? The head is pointing towards the left. Okay, but 1 is not enough. We need to consider 2 special features or related features and consider their related directions. Okay, other than the head, what other positions can I use? Well, you might use the feet, you might use the hands. In my case, I will use my tail. Okay, so let me draw a straighter line like this. Okay, so my tail in A is pointing upwards. Okay, so let's just quickly label all the heads and tails. So for B, where is the head looking at? Oh, I see some answers already, okay? For B, where is my answer looking at? Oh, some of you say you all chose 12 for question 2. Be careful. Number of pieces and number of cuts are different, okay? Here at question 3, you can see that the head is actually pointing downwards. So let's draw out the arrows. The head is pointing downwards, whereas the tail is pointing to the, what is this direction? What is this direction? It is the right. Okay, the tail is pointing to the right. Okay, and for C, my head is pointing upwards. Okay, whereas my tail is pointing to the right. Okay. Oh, right is the direction, but this is my tail. Okay, for D, my head is looking to the right. And my tail is pointing up, down, left, right. Where is it pointing? It is pointing downwards. Okay, down. Whoa, this line is so not straight. Let's draw it again. So my tail is pointing downwards. And for E, my head is looking downwards again. So let's draw an arrow. So head is pointing downwards, whereas the tail is pointing to the left. Okay, so let's label. The tail is pointing to the left. Okay, so now we know that the monkeys are getting rotated. So let's try to rotate everything to the same direction. For example, we know that the head for A is pointing to the left. Let's just change or rotate all the monkeys in B, C, D, and E so that their heads are all pointing to the left. So how do we do this? Let's see. For B, my head is originally pointing downwards. If I want to turn the head to the left, Should I rotate clockwise or anti-clockwise? Which one will be faster? If I'm rotating this direction is faster, right? Is it clockwise or anti-clockwise? Or counterclockwise? You see, if you look at the clock's direction, this is actually clockwise or anti-clockwise? This is clockwise. It follows the clock's direction. So if I rotate clockwise, my head turns to the left, then my tail should turn to, again, I rotate clockwise. And it should go down, right? The tail goes downwards. All right. So immediately you can see my head goes to the left in A and B, but for A, the tail goes up, but B, the tail goes down. All right. So I know that the answer is either A or B. One of them must be different from the others because they are already different to each other. Let's check C. C, my head is already originally pointing upwards. Now I'm going to move it to the left, or rather rotate it to the left. If I want to rotate it to the left, this will be clockwise or counterclockwise. You see, it's a different direction this time. So is it still clockwise? This time it is anti-clockwise. Okay, it's a different direction. So my head now goes to the left. And what happens is my tail will also be rotated anti-clockwise. And where does the tail point at now? It points upwards, right? It points upwards at the top. So C, my tail points upwards. Is it the same as A or is it the same as B? Or rather, A, B, C. Can you tell me which is the different one? All right, the different one is B, clearly, because the tail is pointing downwards, whereas the others, the tail is pointing up. The tail is pointing up. So we know that B seems to be the answer. Let's actually check D and E to see if we can confirm B is the answer. So for D, my head is originally pointing to the right. Let me turn around, okay, and rotate it so that the head is to the left. Okay, my head is to the left, and then my tail should also be turned for half a circle. Okay, let me draw a better arrow. For half a circle, and now it's pointing towards the top, right? Whoa, this is so not the top. So here you can see that the tail is pointing to the top. Okay, so you see again, D, head to the left, tail to the top. It's again the same as A and C. So D is not the answer. D is not different. For E, right, if I turn the head to the left, again, similar to B, I am rotating clockwise. And this time my tail will also rotate clockwise and go up. Okay, so head to the left, tail goes up. And you can see it is the same as A, C, and D. So 4 of them are actually the same, which means the only different one must be B, right? The only different one. I see a lot of answers in the chat. They are very eager to tell me the answer. And you are right. B is the different one. All right. So rotation is actually a 3-mark question because all you need to do is to identify and compare special features. Or if you just want to make it simpler, just turn the paper around and see which image is different from the others when you turn things around. Okay, so when you see a rotation question in TASMO or in other competitions, either label and compare the special features, or you can just turn the paper around, okay, and then rotate it, see which image is different. All right, so since I see a lot of B's here, I think I can move on to the next question, which is question 4. Now, question 4 is a number pattern problem, all right? You can see that we have a farm and the number of rabbits grow according to a pattern. Okay, so it's a number pattern. And it's asking on the 7th day, how many rabbits will there be? Okay, so first of all, can you count for me from the 1st to the 6th day, how many rabbits are there in each day? Type it in the chat box below. What are the 6 numbers? Okay, count it for me. Ooh, I already see some answers in the chat, okay? But what are the 6 numbers in the pattern? The first day, I have 1 lonely rabbit. Okay, I only have 1 rabbit. Okay, what about the 2nd day, and the 3rd day, and the 4th day? What are the number of rabbits? Okay, the 2nd day, I have 1 rabbit as well. 3rd day, 2 rabbits. 4th day, 3 rabbits. 5th day, 5. 6th day, 8. And I'm asking on the 7th day, how many rabbits are there? Okay. Oh, thank you for giving me the number sequence. Okay. 1, 1, 2, 3, 5, 8. That's right. Okay. And what's the next number in this sequence? Now, when you see number patterns, always try to consider what is the change from the first number to the next number. So we are going to do exactly that. Let's change the color. So from the first day to the second day, 1 to 1, is there any change? Is there any change? 1 plus how many is equal to 1? It is plus 0, right? There is no change, so it is plus 0. Okay, what happens from the second day to the third day? We plus 1 this time, right? I see in the chat, 1 plus 1 equals to 2. That's correct. All right, good job. How about the third day to the fourth day? What happens? We have 2 plus how many equals 3? 2 plus 1 equals 3. Right, so plus 1. Okay, now from 3 to 5, is it still a plus 1? No, it is a plus 2. Okay, and then from 5 to 8, what is the change? Plus 3. Okay, so let's take a look at the changes and the trends in the changes. All right, we have plus 0, plus 1, plus 2, sorry, plus 1, okay, another plus 1, plus 2, and plus 3. This doesn't seem to be an easily recognizable pattern. But think about it. What are the numbers that we see over here? We see 1, 1, 2, 3. All right, now I'll give you 20 seconds to find out. Where else can I find 1, 1, 2, 3? These numbers seem to be appearing somewhere else. Where are they? Okay, okay, let me take a sip of water and remember to hydrate yourself as well. Where can I see 1, 1, 2, 3 other than the changes? Someone is telling me you can see that in the actual number of rabbits, right? Let's see, where is that the case? You see 1 on the first day and 1 here as well. 1 on the second day and you see 1 here. 2 in the third day and you see 2 here. 3 in the fourth day and you see 3 here. You see the numbers are actually repeating themselves based on the original sequence. Right, so this is a very interesting sequence. It has a name I will share with you later. But first, can you tell me what is the next number that we should add to the current number? Should we plus 4? What is the next number in this sequence? Is it 4? Let's take a look at the chat. The chat says, oh, good job, right? It is 5. The next number in the sequence is 5, right? Just now we see 1, 1, 2, 3. 1, 1, 2, 3. So the next number in the sequence is 5, which means the next number to add is also 5, right? So we have to plus 5 to find the next day's rabbit number. And 8 plus 5 is equal to, hey, be quick, okay? Calculation. 8 plus 5 is, that's right, it is 13, right? It is 13. 8 plus 5 is 13. So on the 7th day, how many rabbits are there? There will be 13 rabbits, which means my answer will be E. All right, my answer is E. So we have found our answer through this interesting number sequence. And this number sequence is actually what we call the Fibonacci sequence. If you notice, each number in the sequence is the sum of the previous 2 numbers, okay? For example, look at this. 1 plus 1 equals 2, okay? And then 1 plus 2 equals 3. Okay, let's continue. 2 plus 3 equals, you see it's 5, right? So wow, this is an interesting number sequence, right? 3 plus 5 equals 8. 5 plus 8 equals 13, and it goes on and on and on. Okay, so this is about the Fibonacci number sequence. The key here is just to tell you to be more observant in finding the pattern in a series of numbers. All right, so this is the Fibonacci sequence. If everyone is all right, let's take a look at the next question. Okay, you cannot see it, just remember each number is the sum of the previous 2 numbers. Okay, 1 plus 1 equals 2, 1 plus 2 equals 3, so on and so forth. And with that, let's take a look at question 9. Question 9 is actually the question that I received the most inquiries on. Most students ask me about this. Let's take a look at this question. There are indeed a lot of traps, okay? So this question asks us to form two-digit numbers. Whoa, let me underline properly. Form two-digit numbers using the digits 0, 1, 4, and 5 in the blanks below. And we want to add them, let me change. And we want to add them to get the smallest possible value. Okay, note that we cannot repeat the numbers. Each number can only be used once. Okay, so can you first tell me what is your answer for this question? What is the smallest possible value that you can get from this sum? What answer did you get? Oh, okay, answers are coming in. What answers can you get? Some say it is B, some say it is A, but what is the answer actually? Some say E, none of the above. Wow, okay, that's interesting. Let's take a look at this problem carefully, okay? We are asking what is the smallest possible value for this sum, and let's see. First of all, if we want the sum of two numbers to be smallest, should each number be small or large? Should my number on the left and the number on the right each be small or large? Should it be small or large? Type it in the chat. Is it small or is it large? Let's see. Oh, answers are coming in. Of course, right? If I want the sum to be smaller, then the numbers should be each very small. Okay, so let's try to make small numbers out of these digits over here. So let's focus on one two-digit number. All right, 0, 1, 4, and 5. I want to make a two-digit number to be small. Should I focus more on the tens digit or the ones digit? Okay, so let me just say, if you think I should focus more on the tens digit, give me a 1. If you think I should focus more on the ones digit, give me a 2. Okay, should I focus on the tens digit or the ones digit first? Right, of course, the numbers have to be small. Should I focus on the tens digit or the ones digit? Right, which is more powerful to make the number smaller? Of course, it is the tens digit, right? Okay, because even though I use a very, very large one digit, for example, 9, if I give it a very small tens digit, for example, give it 1, and then it's just 19. Okay, it's still small. So I should focus on the tens digit first. So tens digit should be as small as possible to make the number small. Oh, okay. What's the smallest digit? 0. Then can I just put 0 over here? Well, 0 is the smallest digit I can use anyway. Can I say 0 at the tens place? Type it in the chat, yes or no. Think about it. This is the most horrible trap in this question. All right, can I put 0 in the tens place? Give me a yes or no in the chat. Oh, somebody said no. Somebody said nah. Why? Because see, we are forming two-digit numbers, okay? Can my 0 be in the tens place of a two-digit number? Of course not, because when we form numbers, the highest place value cannot be 0. Okay, so even though we want a number as small as possible, take note, okay, be very careful. The highest place value cannot be 0, which means we should consider the next smallest number or next smallest digit instead. And what is the next smallest digit? I see a lot of no's, okay? Thankfully, you guys are clear. 0 cannot be in the highest place value. So the next smallest digit must be 1. Right, so I will put 1 in the tens digit of one number. How about the other number? What other digit can I put in the other number's tens digit? I use 1 here. Can I use 1 here again? Cannot, right? Because each number can only be used once. So I need to consider again the next smallest digit, which is 4. Right, so I have filled up the tens place. So let's continue with the ones place. So we have 0 and 5 left. Actually, you can fill in 0 here and 5 here, or you can fill in 5 and then 0. Okay, they will each give you the same answer, which will be, what is the answer? What is the smallest possible value you can get? 10 plus 45, 15 plus 40. Let me look at the chat. Okay, a lot of B's. What is B representing? 15 plus 40 equals 55, right? So I know that my answer is B. The smallest possible value is B, which is 55. Okay, so hopefully after my explanation, it's clearer for this question. Be very careful, okay? Start from the highest place value, but also remember, 0 cannot be placed at the highest place value. All right? Okay, the answer is not C, unfortunately. Okay, if you did C, maybe you did 41 plus 0.5, but then again, 0 cannot be at the highest place value. Okay, some of you might get A because you all said 14 plus 5. Again, 0 cannot be the highest place value. Okay, so this is the key to this question. And with that, we have gone through all questions in section A. All right, so let's prepare ourselves for section B. Okay, section B is on short answer questions. And the next question is going to be something that you all will find very familiar. Okay, so let's take a look at question 17. Oh, matchsticks. Okay, did you all attend last week's live stream with Teacher Ollie? Yeah, in that live stream, Teacher Ollie taught you all how to use matchsticks to form numbers. And let's just have a quick review. The numbers 0 to 9 can be formed using matchsticks like this. But this question is slightly different. It is asking, if I give you TASMO, okay, and yes, 10 plus 45 is correct, okay? If I give you TASMO, at least, let me underline the keywords for you, at least how many matchsticks need to be moved to form a 5-digit number, okay? So let's have a deeper dive into this question. At least how many matchsticks need to be moved? That means, do I need to touch few or many matchsticks? Is it few or is it many? Okay, at least how many? That means, should I touch as few as possible or as many as possible? Okay, this matchstick problem is one of the challenging problems in this question. So let's take a look at this together. At least means I'm going to touch as few matchsticks as possible. Okay, some of you are typing the number in the chat. Okay, we'll look at it later. Okay, so how many matchsticks need to be moved? What does it mean to move the matchstick? Can I just take the matchstick away? Can I just say, oh, I'm going to take away one matchstick like this, and then I never put it back? Is it possible? Right. Is it possible? No. What does move mean? Okay, tell me in the chat box. Move means if I take it away, do I need to put it back? Yes or no? If I move the matchstick away, do I need to put it back? No. Move and remove are two different things, okay? If I say remove, that means I take away and I don't put it back. But now I'm saying move, okay? The difference is when I say move, then I move it away, I need to put it back somewhere else. Okay, so I don't change the number of matchsticks. I will just need to move it somewhere else. Okay, so let's take a look at this TASMO pattern over here. Given this word, how many matchsticks at least, do I need to move to form a 5-digit number? At least how many to form a 5-digit number? So my first question to you is, what do you notice about each digit? Look at digit 0. How many horizontal matchsticks can you find? Put together. 2, 3, 4, 5, 6, 7, 8, 9. How many matchsticks can I put horizontally together next to each other? Can I put 2? Can I put 3? Or can I only put 0 or 1? Right, take a look at the horizontal matchsticks. Can I put 2 of them together to form a digit? Yes, really? Hey, actually no. Okay, because look at 0, 2, 3, 4, 5, 6, 7, 8, 9. In each digit, only one matchstick is placed horizontally next to each other. I cannot have 2 matchsticks next to each other. So like something like this. Okay, this is not correct when we form our digits, which means when I see 2 matchsticks horizontally placed together, I must take away one of them. Right, so that it can become a real digit. Which begs my next question. See, in this T, there are 2 matchsticks that are horizontally next to each other. I must move away one of them, right? Do you think I should move matchstick A or matchstick B? Which way will make me move fewer matchsticks? Do you think it's better for me to take away A or take away B? Type it in the chat box below. Which one should I do? Which one should I take away? Right. I see some numbers coming in. Keep it up. What answers do you think? Oh, okay. Majority of you say I should take away B. Why is this the case? Let's see. If I take away B, I take away B. Okay. So, whoa, I take away B. What do you notice about the remaining matches? What do you notice? Is this a digit now? What digit is this? Right, it suddenly become the digit 7, which means by just moving one matchstick, I can make a number. So I write 1 here to keep track. I took away one matchstick, or I moved one matchstick, and I need to put it back. Okay, remember, I take away one matchstick, but since I'm moving a matchstick, I should put it back. But where should I put it? Maybe we should look at the next digit for our ideas. The next symbol over here is an A. Do you think this is a digit? Is this one of the digits over here? No, right? Okay, then how can I turn it into a digit? Can I remove some matches? Or would it be better for me to add one match that we take away just now? Oh, I see some answers. 8, 8, 8, 8, 8, right? You see, this A sort of looks like an 8, but with one matchstick missing. And we just took away one matchstick, so why not? I just put this matchstick over here, 8. Okay, and look, we formed another digit. Okay, so since we have 2 digits over here, let's not touch them anymore. We move to the next digit over here. This digit, is this a digit? Right, take a look. This is digit 5 exactly. Even though it's an S, but it's also, we can also read this as a 5. Right, so this 5 over here, we don't need to touch it because it's already a digit. Okay, we shouldn't move that many matchsticks. So let's move on to this M. Aha, look at this M. There are 2 horizontal matchsticks placed together. So do you think I should take away one of them and move them somewhere else? Should I do something to these 2 matchsticks? Should I do something to them? Right, I should do something to them because 2 of them are horizontally next to each other. I don't want that in my digits, so I should actually do what? I should actually, whoa, okay, let me add this matchstick back. I should actually take one of them away. And remember, if I'm taking one away, I will need to put it back somewhere. Okay, so I take away another one matchstick and I'm gonna put it somewhere else. Where should I put it? Can I put it in this part over here? Or can I put it in this part over here? You see, I want to put this matchstick away somewhere else, right? But can I put the matchstick in this part so that it becomes a digit? Can I put it here? Or can I put it here? Oh, that's not a digit. Can I put it here? That's still not a digit. Maybe I shouldn't put it here. Okay, I should put it in the O instead. And can I add this matchstick somewhere to this O to form another digit? I mean, this is a 0, but can I add the match to it to turn it into another digit? What other digit can it become? It becomes an 8. Oh, someone say I want to turn this into a 9. Maybe not, because if I put the matchstick over here, is this a 9 yet? No, take a look. 9 has the match below. All right, so this is still not a 9. But maybe we can put this matchstick somewhere else. I can put it in this 0, and I turn this into an 8. Right, so I turn this into an 8. I have put this second matchstick somewhere else. Okay, but now that we have found 5 digits, okay, 5-digit number, I have 5 digits. Are we done? Can we just say, oh, we are done, there are 2 matchsticks? Absolutely not, all right, because there is still this weird little thing over here. Okay, we need to turn this into a digit. And also there are 6 symbols. We only want 5 because we want a 5-digit number. So let's consider this part over here. This is not a digit. Do you think we should move all these matchsticks? Or is there a better way to do this? If I move all of these matchsticks, I will move 1, 2, 3, 4 matchsticks already. But do we really need to move that many matchsticks? Or can I touch any other digit over here? Any other position can I touch? Oh, someone say move 4. Okay, move 4. I have 2. How can you move the other 2? There are 4 over here. Maybe I don't need to move that many matches because take a look. 1 over here. How many matchsticks are in this one? 2 of them are in this one, right? So I actually can move these 2 matchsticks to combine with this part over here and turn this number into a digit so that we just need to move fewer matchsticks. Now, if I move these 2 matchsticks over here into this non-digit, what digit can I turn it into? Oh, someone say move to 5. If I move to 5, this part is still not a digit. So I cannot. I have to move these 2 into this part. All right. So if I move 2 matchsticks into this part, okay, 2 matches into this part, what number can I form? Someone says 0. Good job. Okay, I see the answer already. I can actually use these 2, move them away. So let me just make a cross to show that I'm moving them away to form 0, right? You see 1, 2, and now this becomes a 0, okay? Other than 0, I can also form, right? Someone already tell me another answer. I can form 9, right? 1, 2, I form 9. So either way, I can move 2 more matchsticks to form another digit. And now we have our 5-digit numbers, okay? 78598 or 78508. Okay, so how many matches did we move? Thankfully, we recorded them over here. So 1 plus 1 plus 2, that is how many matchsticks? We have moved 4 matchsticks, okay? All right, so remember when you want to do things like shifting, taking away, remember to record your progress over here so that you don't forget how many matchsticks did you touch earlier. All right, so this question is, I would say, very, very challenging. Did you get it right? Okay, did you also get 4 matchsticks? If you didn't or you haven't done yet, okay, take a look at this question, think about it, and then maybe use this as a review. Okay, so let's take a look at question 18 now, which is a more classic competition question. We have a figure below that is formed by 4 parts, okay? And we are asked, how many triangles are there in the figure below? Okay, can you just say, oh, I have A, B, C, D, 4 parts, so 4 triangles. Can I say that's the case? Maybe not, right? So in this case, we should actually do things more systematically. Okay, we consider part by part. What part by part do I mean? Level by level. So let's consider first. A, B, C, D, there are 4 parts. How many triangles can I form using only 1 part? Okay, that's the first thing we should consider. But also, you will notice that there are some bigger triangles. Okay, for example, A and B. Okay, this is a bigger triangle. So it seems that I can form a bigger triangle using more than 1 part. Right. Oh, I see some answers in the chat. Okay, let's see if you are correct. So if that's the case, how do I do this? Like I said, we consider level by level. So let's take a look at how many triangles can be formed using one single part. So is A a triangle? Yes, A is a triangle. So 1 part, A is a triangle. Is B a triangle? B is also a triangle. And is C a triangle? Right, C is also a triangle. Is D a triangle? Not quite. You see, 1, 2, 3, 4. 4 sides. So D cannot be a triangle. So maybe these are all we can find for 1-part triangles. But can we just say our answer is 3? No, like I said, right? We have some triangles that can be formed using 2 parts. That's why I see some of you in the chat saying that there are 3 triangles. No, okay, because some of them can be formed using more than 1 part. For example, A and B, like I just said, A and B. A plus B, that will give me a bigger triangle. Let me try to draw it out for you, okay? This is a bigger triangle. Right, so A and B form a bigger triangle. Can you give me other bigger triangles that can be formed using 2 parts? Okay, type it in the chat. Okay, what triangles can be formed using 2 parts? Other than A plus B, what other 2 parts can form a triangle? For example, can B and C form a triangle? Maybe not. B and C, they are separate. Okay, what other two parts can form a triangle? A and B, what else? C and D, good job. You see C and D, that's another triangle. So C and D, right? Anything else? There's more. A, B, C, D. Oh, that's four parts. Okay, we'll get to that later. Any other triangles that can be formed using two parts? There is. Okay, where is it? B and C, right? B and C. Are you sure? No, but I see B and D. B and D forms another triangle. Good job, B and D. And I also saw A and C, right? They also form a bigger triangle. Okay, what else? Anything else? Or is that all? That's all right. So that is actually all for the two-part triangles. Okay, next let's consider, are there any three-part triangles? Three-part triangles, are there any? Can I say A, B, C form a triangle? Whoa, totally not, right? Because you see, clearly it has more than three sides. How about B, C, D? Or A, C, D? Or A, B, D? Can I put anything here? Think about it. Give your opinion in the chat below. Can I form any triangle using three parts? Ah, I see a big no in the chat. Okay, that's correct. I can form nothing, right? Nothing involves three parts. But don't give up yet, okay? There are four parts in total. Can all four parts form a triangle? Okay, I see just now somebody say A, B, C, D. ABCD is a big triangle, right? So that is also a triangle. A plus B plus C plus D is also a triangle. Okay, so are we done now? We are of course done. There are only four parts, so we can stop here. Okay, the four-part triangle. So how many triangles are there in total? Let's count again, level by level. For one part, we have 1, 2, 3. So 3 triangles. For two parts, we have 1, 2, 3, 4. 4 triangles. For 3 parts, no triangles. For 4 parts, we have 1 triangle. So in total, how many triangles do I find in the figure below? How many are there? Oh, I see somebody giving me a lot of the correct answers. How many are there? There are 8 triangles, right? 3 plus 4 plus 1 equals 8. All right, so there are 8 triangles. Okay, so hopefully after this explanation, you find these kind of questions more manageable. Okay, always consider one part, two part, three parts, etc. Okay, just do it systematically. Okay, and list them down. Okay, so that it's easier for you to count them later. All right, list them down. Okay, make the good habit to list them down. All right. All right, so everyone is okay in the chat. So let's perhaps move on to talk about Section C questions, okay? This is actually Section C, all right? There are 3 questions that I would like to talk about in Section C. The first one is a art gallery problem, okay? Very long question, but let me tell you, even if you see a long question, be patient, okay? Read the question, underline any keywords you see because they will all be helpful in your problem solving. So let's read the question. Think Academy Primary 1 students are at an art gallery for a learning journey. On the wall, there are 17 art pieces hanging in a straight line from left to right. Okay, let me underline better. From left to right. Now, while exploring, Little Miss Clumsy got lost. Read the conversations below and calculate how many paintings are there in between Little Miss Clumsy and her teacher. So how many paintings are there between the two people? Let's read the conversations, okay? There are 4 paintings on the left of Miss Clumsy. 4 on the left compared to this painting that Miss Clumsy is at. For the teacher, they are at the 5th painting from the right. Okay, 5th painting from the right, which means this is the 5th painting. Okay, so how many paintings are there in between them? Okay, good question. Let's take a look. So there are 17 paintings in total, and we want to find out how many paintings in between. So this is actually a queuing problem. We have some number of things in a row, and we want to find out how many things are there in total or in a certain part. So for this type of question, my advice is to always draw out the diagram. Okay, so let's consider drawing up the diagram. There are 2 main characters over here, Miss Clumsy and teacher. So let's label that Miss Clumsy and teacher. Okay, so how many paintings are there on the left of Little Miss Clumsy? There are 4 paintings on the left. Okay, so 1, 2, 3, 4 paintings on the left of Miss Clumsy. All right, let's move on to the right. Okay, the teacher says this is the 5th painting from the right. Whoa, whoa, whoa. 5th painting from the right. So, 5th painting, right? Number 5, right? Can I just draw 5 paintings over here? Can I say, hey, that's a 5 paintings? If you think this is correct, say yes. Okay, if you think so, if you think it is not, okay, just say it's not correct. Okay, and don't make any rude comments in the chat. All right, let's be more mindful of what we speak. Okay, and let's see. I am the 5th painting from the right. Does that mean I should have 5 paintings? No. Okay, I see a lot of no's in the chat. Good job. Why is it no? Because it's the 5th painting, right? So naturally, we count from the right, okay? First, second, third, fourth, 5th. Then we stop at the 5th. Teacher is at painting number 5 from the right, which means there should be only 4 paintings on the left, on the side, on the right side. Okay, so number 1, number 2, number 3, number 4, and number 5. All right, so now that we have found out how many paintings are there at the sides, we just need to figure out how many paintings are there in the middle, between Miss Clumsy and teacher. How many paintings are there? So let's first count how many paintings are there on each side. On the left, how many paintings are there up to Miss Clumsy? Up to Miss Clumsy, how many paintings are there? Right, the teacher is the 5th painting, so the right should be 4. Good job, right? Detailed explanation. So you see 1, 2, 3, 4, 5. There should be 5 paintings on the left. How about on the right? Is it 4? Is it 5? Is it 17? Let me see the chat. Right, now we have 4 paintings on the right, including the painting over here. So there should be also 5 paintings. Okay, so 5, how many are there in the middle? Is there other information that we didn't use yet? Right, you see how many paintings are there in total? There are 17 paintings in total. So that means all together over here, all together, I actually have 17 paintings. Okay, oh, everyone already gave me the answer. So 17 paintings all together, 5 on the left, 5 on the right. How many are there in between? We just do, if I have the whole, I have some parts. I want to find one part from the whole. Should I use addition or subtraction? Should I use plus or minus? Okay, should I use plus or minus? I should use minus, right? Okay, a lot of you say 7. How do you get 7? You just do 17. Oh, hold on. 17 minus 5, which gives me 17 minus 5 is 12. 12 minus 5 is 7. Okay, so I know how many paintings are there in between. There are 7 paintings. Okay, there's a blank over here. Let me fill it up as well. 7 paintings. Okay, all right. So this question, even though it is not about queuing up in a line, this is also a queuing problem. And when we talk about queuing problem, 2 advice I want to give you. First, draw the picture out so that you better visualize the question so that you can solve it better. Secondly, be careful. Is it talking about ordinal numbers, so first, second, third, or is it talking about cardinal numbers like 1, 2, 3, 4? Because depending on what words are used, we should consider the number of paintings differently. All right. Okay, so 7, 7, 7, 7, 7. That's right, the answer is 7. Good job, everybody. So queuing problem, hopefully y'all can have a better idea. Let's take a look at question 24. These are the last 2 questions that I would like to go through today. So in this question, we have 3 sisters, 3 girls, okay? Cynthia is 5 years old. So we have Cynthia, okay? She has 2 cousins, Cheryl and Athena. So Cynthia is 5 years old, and there's also, hold on, let me write a better 5. years old. She has two cousins, Cheryl and Athena. Okay, Cheryl's age is 2 times Athena's age. What does this sentence mean? Cheryl's age is 2 times Athena's age. Think about it. If Athena is 1 year old, for example, if he is 1 year old, then how many years old is Cheryl? How many years old would Cheryl be if Athena is 1 year old? Cheryl's age is 2 times Athena's age. Okay, if it is 2 times Athena's age, this is 1. Thank you. I see someone in the chat saying it is 2, which is correct because it is just 2 times 1. Okay, so Cheryl's age will be 2. That's just 2 times 1. Now, what if Athena is 3 years old? Then how many years old would Cheryl be? Is it 12? Really? Think about it. 2 times 3 years old. So that will be 6 years old. Right. Okay. So how do I get Cheryl's age from Athena's age? I will just times 2. Right. To get from Cheryl's age, to get from Athena's age to Cheryl's age, we multiply by 2. So we know the relationship. But do we know what is the total age of these 3 children? Yes, the total is 23 years old. The total is 23 years old. So how old is Cheryl now? Okay, pay attention. We are looking at Cheryl's age. So Cheryl's age. Now, Cheryl's age is 2 times Athena's age. Do I just try one by one? 1 times 2 is 2, 2 times 2 is 4, and then add up to find the answer? Maybe not. Okay, so from the total age of 23 and Cynthia being 5 years old, can I find out the total age between Cheryl and Athena? What is the total age between them? Total age of Cheryl and Athena. How do you find their total ages? Oh, no, you can find it, okay? Total is 23 minus 5, so it is equal to 18. Good job. Thank you. We just take 23 minus 5 equals 18. Right. So 18 is the total age. But then how do we know what is the what is the age of each of them? This is where I will introduce to you the bar model. So how do we draw the bar model? Let's just give a brief run through. First of all, we are comparing the ages between Athena and Cheryl, right? So we just write their names first, Athena and Cheryl. Then we will use a rectangle, a bar to represent Athena's age. So this bar represents some number of years, okay, and Athena has 1 bar. I don't know how many years does this bar represent, but I just draw 1 bar first. Okay, later we will figure out how many does it represent. So if I draw 1 bar for Athena, how many bars should I draw for Cheryl? Keep in mind, Cheryl's age is 2 times Athena's age. So how old, or rather, how many bars should I draw over here? Should I draw only 1? 2 times Athena's age. Okay, so 1 time is 1 bar. 2 times the age means 2 times 1 bar. I need to draw double the number of bars, so I should draw 2 bars, right? Okay, so how do I draw 2 bars? Should I draw my first bar like this? Well, maybe not, okay? It's easier if you align them according to the same line. So that's why we have a dotted line over here, is to make sure they start from the same starting line. So I start like this. All right? Moving on, second bar. Can I draw it like this? Okay, first bar longer, second bar shorter. Is that okay? Well, that's not okay. All right, I see a lot of you making great reactions. No, of course not, because it is double, right? How is this double of Athena's age? Right, so they should be the same size. Okay, and can I draw my bar like this? Maybe not. Okay, because if I draw like this, I don't know if it's belonging to Athena or Cheryl. Okay, Cheryl has double, so I make sure to make it side by side, okay, next to the previous bar for Cheryl. Okay, so now that we have drawn the model, 1 bar or 1 rectangle for Athena, 2 bars for Cheryl, how can I find the total of these 3 bars? Is it given to us? The total will be 3 bars, which is 18, right? We found it earlier. The total age is 18. So the total is 18. And how many bars are there to count towards 18? How many bars account for 18? Take note of the units. It's not hours, it is years, okay? So 3 units actually, you see 1, 2, 3, 3 units. So 3 units is equal to 18, okay? And if 3 units is equal to 18, or rather 3 rectangles is equal to 18, if that's the case, can you tell me what is the value of one rectangle? 3 same rectangles is 18. What is the value for each rectangle? Do I use multiplication or division here? Right, 6, right? How do you get 6? Because you use division, right? 18 divided by 3. 3 same rectangles give me 18. Each of them will be 18 divided by 3 equals 6. Okay? So can I just say my answer is 6? I'm so done. Okay, 1 unit is 6 years old. So answer is 6. Is that okay? Can I say I'm done? Don't, okay? Read the question properly. Cheryl, okay? I'm finding Cheryl's age. Is Cheryl 6 years old? No, okay, because you see, Cheryl has 2 units. So 1 unit or 1 rectangle is 6 years old. How about 2 rectangles, which is the actual age for Cheryl? 2 rectangles is equal to, that's right, you should use division. But now, just now we use division to find 1 unit or 1 rectangle. Okay, for 2 units or 2 rectangles, each rectangle is 6. So 2 rectangles should be how many? Okay, the correct answer. We are almost there. What's the answer for this question? Okay, it should be 2 times 6 equals 12. Okay, I see some answers in the chat. Thank you so much. Okay, indeed, 2 rectangles will be 2 times 6, and that gives me 12 years old. Okay, so with that, we have found the age of Athena, Cheryl, and Cynthia. And Cheryl is 12 years old. All right, so this is a classic model question that I'm sure you will see more and more throughout your Math Olympiad journey or even in your math learning journey. So it's important to master this skill. So hopefully this is going to increase your understanding. Okay, so remember, draw your models to represent any multiple relationship. All right, if you see multiple relationship, draw the unitary model. Okay, which is basically this units, rectangles, models. And each rectangle must be the same size, all right? Okay, so with that, let's finally move on to our last question of the day. Here we have a number matrix, okay? So this number matrix, we are going to fill in some numbers, 1, 3, 5, 7, 8, 9, 11, into the circles below, so that the sum of the 3 numbers on each line equals to 20. What is the middle number? I am looking for the number in the middle. Aha, those of you who have just joined our MHA lesson last week, hopefully you know how to do this question. Okay, we have just learned that days ago. All right, so hopefully you have got this correct. But for the others who may have not learned how to do number matrix questions, let's think about it first. Why is the middle number so special? Why am I so interested in the middle number? Okay, we take a look, right? There are 3 lines in this number matrix, and we want to make sure the sum along each line is equal to 20. Right, so if that is the case, let's look at the lines. Okay, the first line is this horizontal line over here. So it includes 2 circles at the side and the number in the middle. Okay, oh, y'all are already giving me the answers, okay? But let me just go through how usually this works, okay? Just to give you a quicker way to solve problems like this, okay? Now look at the second line from the top right to the middle. Again, it passes through the middle number. Oh, that's why it's special. You see, every line has the middle number in it, right? If I take a look at the third line at the bottom, again, it includes the middle number. So that's why the middle number is actually very special in the number matrix. And if you want to fill up the number matrix, we always start from the middle. Okay? But here's my next question. I know I should start from the middle. Should I actually try the numbers one by one? Maybe not. There's a strategy to this, and the strategy depends on what numbers are given to you. So here's a little exploration. Who goes to the center? All right, there are two cases. Let's look through them one by one. Okay, for the NHA kids, treat this as revision. All right. In the first case, we have a constantly increasing pattern. So let's say I give you the numbers 1, 2, 3, 4, 5, 6, 7. Let's go through the pattern again. From 1 to 2, what happens? I plus how many? Plus 1, right? Okay, 1 plus 1 is 2. From 2 to 3, what happens? I plus 1 again. Okay, 3 to 4, plus 1. 4 to 5, plus 1 again. Okay, and then plus 1, plus 1. I see some of y'all are curious why the answer is that answer. Okay, don't worry, I'll go through with you together. So, if we have a constantly increasing pattern like this, every number is plus 1, plus 1, plus 1, plus 1 to the next number, then what's the strategy to choose the middle number over here? The strategy is to try the first, middle, and last number. Try the first number in the sequence, the exact middle number in the sequence, and the last number in the sequence. Okay, so what's the first number in the sequence? The first number of the sequence is right, all plus 1 exactly. So we try the first number, middle number, and the last number. And the first number will be 1, right? The most important, the most front number. How about the middle number? The number in the exact middle will be 4, okay? And finally, the number at last, the final number, it is 7, okay? So when we have a constantly increasing pattern, we don't need to try out every number in the middle, okay? I only need to try out these 3 important numbers, the first number, the middle number, and the last number. So 1, 4, and 7. Okay, so these 3 numbers can go in the middle. We can try it and then pair the other numbers out. All right, okay, so pair them out and put in each line for the other numbers. Now, if I have a non-constant pattern, what does it mean by a non-constant pattern? Ooh, spoilers, okay? If I have a non-constant pattern, let's see. From 1 to 3, what is happening? Is it a plus 1? Is it a plus 1? No, it's a plus 2, right? 1 plus 2 equals 3. What about 3 to 4? What's happening? What's happening from 3 to 4? Is it still plus 2? Maybe not. This time it is plus 1, okay? So, how about from 4 to 5? 4 to 5 is plus 1. 5 to 7, oh, suddenly it goes back to plus 2. Right, and then 7 to 9, it is a plus 2. And 9 to 11, is it plus 1 or plus 2? Again, it is plus 2. Now, this pattern is not that constant, right? Sometimes it is plus 2. Sometimes it is plus 1. Oh, if that's the case, can I still try the first, middle, and last number? Can I still do plus? Find the first, middle, and last number? Think about it. Maybe that is not how it works. Oh, somebody says 1, 5, and 11, right? You all want to try the first, middle, and last number. But let me tell you, no, that is not the case, okay? Because this time we are not having a constant pattern. Okay, we are, if it's a constantly increasing pattern, everything is plus 1, plus 1, plus 1, or plus 2, plus 2, plus 2. Then you try the first, middle, and last number. If I have a non-constant pattern, here's what I do instead. Can you take out any one number so that the remaining numbers form a constantly increasing pattern? Take a look. We have students, good students, right? These numbers are all good students that are following the order, except one of them. They are disturbing the order. They are not following the order. Can I take away one number out so that the remaining numbers can form a better order? Okay, you see, I have plus 2s everywhere except 3 to 4 is plus 1, 4 to 5 is plus 1. It seems that I have a naughty student over here. 4 is naughty. It's not following the order. Why is it the case? Let's say if I take away 4, 1, 3, 5, 7, 9, 11. Let's take a look at what's happening to the order of the remaining numbers. So from 1 to 3, what happens? 1 to 3 is a plus 2. 3 to 5 is a... Oh, suddenly you see 3 to 5, it becomes a plus 2. Then 5 to 7, 7 to 9, 9 to 11, we found it before. They are all plus 2s, right? They are all plus 2s. So suddenly, if I remove 4, the other numbers will form a better looking pattern. It is a constantly increasing pattern now. So maybe this 4 is indeed special. It's the only naughty number or naughty student among these numbers. Okay, so you see, after we take away 4, the order becomes constant. So this 4 is not following the order. It's a naughty student. And what should we do with naughty students? Okay, if I see a naughty student in my class, I will invite the naughty student to stand in the middle of the classroom. Right, so because they are naughty, okay, this is a punishment to them, just to warn them to be following orders better in class. Okay, don't make any mess. So similarly, you see this number is making a mess among these patterns. So let's take away this naughty number and we put it in the middle. Okay, so when I see a non-constant pattern, find if there's any number that disturbs the order, that makes the pattern not constant. Then take the number out and put it in the middle. All right? Okay, so with this constantly increasing pattern and non-constant pattern, keep this in mind. And let's get back to question 25. Here we are given the numbers 1, 3, 5, 7, 8, 9, 11. Let me write them up clearly. 1, 3, 5, 7, 8, 9, 11. Do you think we should find the head, middle, and tail, or the first, middle, and last number? Or should we find the naughty number? Okay, if you think we find the first, middle, and last, type it in the chat. If you think we should find the naughty number, also type it in the chat. Most of you are saying naughty numbers, naughty numbers. You all have also found the naughty number, okay? So let's go through this quickly. Well, from 1 to 3, what happens is we plus 2. 3 to 5, plus 2. 5 to 7, plus 2. 7 to 8, is it still a plus 2? Is it still a plus 2? No, it's a plus 1. Suddenly it becomes a plus 1. What's going on? From 8 to 9, what do I have? Also a plus 1. But then from 9 to 11, is it plus 1? No, it's suddenly a plus 2 again. Oh, so you see, the pattern is non-constant. So maybe we should pick up a naughty number. And what is the naughty number in this case? Right, I see some naughty numbers. I see some 8s. Okay, some of you are suggesting that the number is 8. Why is this the case? Let's see. If 8, I pull it out first. What numbers are left? I have 1, 3, 5, 7, 9, 11. Okay, and then let's try to find a pattern among them. 1 to 3, we found it, plus 2. 3 to 5, plus 2. 5 to 7, plus 2. How about 7 to 9? Okay, I took the 8 away. So from 7 to 9, this becomes plus 2, right? And then 9 to 11 also found it plus 2. You see, the pattern now becomes a constantly increasing pattern. They are all the same, plus 2, plus 2, plus 2, plus 2, plus 2. So indeed, 8 is a naughty number. And what should we do to the naughty number? We just put it in the middle, right? So I put it in the middle. So 8 is the middle number. So, of course, you can put 8 as your answer immediately because it's asking for the middle number. Okay, but then let's check our answers to see whether 8 is indeed the middle number. Let's see. If I put 8 in the middle, do I know what is the sum of these two numbers? Do I know that? What should these two numbers add up to? The sum is equal to what? If I know that 8 is the middle number, and remember, the sum of the three numbers is 20, right? Along each line, the three numbers should add up to 20. So what is the sum of these two numbers? I see answers coming in. Good job, 12. Right, this is the last question. Okay, so after this, I will just go through what are the remaining plans of the week. Someone say put 3 and 1. Is it the case? Let's see. If I put 8 over here, the sum of the three numbers is 20. So these two numbers should add up to 20 minus 8 equals 12. Right. So I want to find two numbers that can add up to 12. Can I find which two numbers can add up to 12? How many plus how many equals to 12? Can I use 8 again? Maybe not. Okay, I have 6 numbers. I should use them instead of 8. Among these two numbers, or these 6 numbers, who and who can add up to 12? Ah, I see some interesting answers coming in. 5 and 3, do they add up to 12? Think about it again. 7 and 5, that's right. 7 and 5 add up to 12. So they form a pair that I can fill into these two circles along a line. Okay, other than 7 and 5, what other numbers can add up to 12? 1 plus 11. I see complete answers 1 plus 11 and remaining two numbers 3 plus 9 equals 12. Okay, thank you so much for your answers. So indeed, 1 and 11 can be a pair, 3 and 9 can be a pair, and we found that all three lines, each of them add up to 20. So indeed, we can confirm the middle number is 8. All right, and that's how we solve question 25, a question on number matrix. So for number matrices, always remember to start from the middle number. Either we try the first, middle, and last if it's a constantly increasing pattern like what we show here, or if it is a non-constant pattern, find the naughty number. Okay, find the naughty number and put it in the center of the number matrix. Okay, and with that, hopefully we have a fruitful journey so far. That is the end of our live stream. But wait, here are some reminders for you. Okay, first of all, if there are any further questions that you would wish to receive advice on or other answers on, ask them in the group chat, okay, either WhatsApp or WeChat. Okay, if you haven't joined any group, please reach out to our Think Academy customer service team and we will add you to the group. All right. Otherwise, you can also reach out to our teachers. Okay, we are all in the group chat to help. Okay, and some of you might be itching to try out the next sample paper. That's right, we will have our next sample paper with completely original questions, and it will be sent to you or sent to the group chat on Friday. Okay, so stay tuned for the next paper on Friday. And as usual, next Tuesday, we will have a live stream to talk about some challenging questions in that paper. All right, so with that, that's the end of today's live stream. If you have learned a lot today, please give me some thank yous or some thumbs up or any comments in the chat. Okay, I would really appreciate that. Okay, and with that, that's the end of our live stream. Okay, have a restful evening and we will see you when we see you again. All right, goodbye. Hey, please be polite, okay, to your teachers, all right? You wouldn't wish to treat others, you wouldn't wish for others to treat you like that as well. So, yeah, please be polite, okay? All right, have a restful evening.